Good morning, dear students. Today we will discuss about the second type of problem, that is an assignment problem, that is module 3 in operation research. Okay, now I will read out the question here. A project work consists of 5 major jobs which are 5 contractors have submitted a tenders. The tenders amounts quoted in a lakhs of rupees are given in the below table. Find the assignment which minimize the total cost of a project, and each contractor has to be assigned at least a one job. Okay, so here 5 jobs are there and 5 contractors are there. They given each job each person. Okay, now the meaning of question is to allot the each job to each contractor person and to minimize the total cost. That is the main objective of this question. Okay, so how to solve this type of problem? Okay, we will solve this type of problem step by step. Okay, first step, you have to check whether the given problem is balanced or unbalanced. How to check that is the given problem is balanced or unbalanced means number of rows should be equal to number of jobs. Okay, here number of rows is equal to 1 2 3 4 5 are there, and number of columns is how many? 1 2 3 4 5. So number of rows is equal to number of columns, so hence the given problem is balanced one. First step is over. To solve any assignment problem, first you check the number of rows is equal to number of columns. Okay, if it is not there means you add dummy column or dummy row to make it balanced. That is the first step. Second step is called as a row reduction method. Okay, now from write down as it is in the given box here. Okay, now so find the each minimum least value from each respective row and write down the side. Okay, so from the first row minimum value is 7. Okay, from the second row minimum value is 6, from the third row minimum value is 6, fourth row 9, and last one is 7. Okay, so just to check it, 9 11 14 11 7 is the minimum right here, 7 value. Okay, next subtract the least value from the remaining values of that respective rows. Okay, now so the new matrix has come here, that is modified matrix, by subtracting the minimum value or least value to the respective row of the original values. Okay, 9 minus 7 is equal to 2, 11 minus 7 is equal to 4, 11 minus 7 is equal to 4, 7 minus 7 is equal to 0. Similarly 6 minus 6 is equal to 0, 15 minus 6 is equal to 9, 13 minus 6 is equal to 7, 7, 6. Like that you subtract least value of the respective rows of their original values, you will get a new matrix. Okay, now this is the first step. Second step is we did this row reduction method. Similarly you do the column reduction method. Write down the least value of column, write down this matrix as it is in the third step, that is called as in a third step. Okay, third step is called as row reduction method, column reduction method. Write down what you got in a modified method, write down as it is, and minimum value write down here. Okay, minimum value for the first column is 0, minimum value for the second column is 0 0, from this third tabular column is least value is 2, here also 0. Again same, subtract the least value from the respective column. Okay, so here 0 is there, subtract any value from 0 means you will get same value. Okay, na 2 minus 0 is equal to 2, 0 6 2 0. So here only this is the only difference is there, that is the least value is 2 is there. 4 minus 2 is equal to 2, 7 minus 2 is equal to 5, 2 minus 2 is equal to 0, 3 minus 2 is equal to 1 1. This is also 0 is there, right as it is. Okay, this is about the third step. Next is very important steps. So assign a only single zeros in a respective rows and delete the respective column. Okay, na? So here fourth step is very important. First after reduction column method, write down as it is and assign a value such that in each single row only single zero should be there. Okay, na? So look at here first row, so 2 4 7 2 0, only single zero is there, so you assign. This symbol is called as an assignment symbol. Okay, just you assign and respective column you have to delete it. Okay, I am repeat this step. Check the only single zero in respective rows and assign that, and respective column you have to delete it. Okay, check it, look at the first row, only single zero is there, assign this here, this is assignment symbol, assign this and delete respective column. Okay, come for second row, here also only single zero is there, assign that box and delete entire row. Come to third is 2 zeros are there, here 2 zeros are there, don't delete, we want only single zero. And here also in fourth step also 2 zeros are there. Okay, no, here after deleting here only one single is 0, so allowed here assign this 0 and delete entire row. Here no zeros are there. Okay, after assigning a single zero in row, check for the column. Okay, in column this is already deleted, no use. This is also deleted, no use. So come for this is only single zero is there, so assign single zero here and delete respective row. While assigning a with respect to row, delete the entire column, while assigning the column zeros and delete the entire row. Keep it in mind. Okay, so here also not there. So after assigning the assigning the values, you check whether the given solution is optimal or not. Okay, how to check it? Here number of rows are 5 are there, and number of assigning values are 1 2 3 is there. So 3 and one more is 4 is there. 4 is not equal to 0. So this again still it is not a optimal solution. Make it optimal solution is go for step number 6. Okay, in step number 6, what you are doing is find the minimum value and add the number of intersection of that minimum value to the intersection point and subtract the unrelated column we get. Okay, now this is a modify matrix. From these steps I will going to repeat this number. Step number 6 is, so if you want to stop here means number of assigned value should be equal to number of column, but here assigning value is 1 2 3 4 is there, but is equal to 5 rows are there, so it is not possible. So go for the next step. Okay, and next step, find the least value of unrelated column or unrelated rows or column. Okay, so here this is related, no use, this is related, no use, and this is related, no use. So check for only these two. So among these two only the least value is 1 is there. Okay, so 1 you add where the intersection line digit and subtract the unrelated rows. Okay, now so here intersection line is here 6 is intersection line, and one more is 2 is one more intersection line. Okay, so only 2 are there and unrelated value is here. So here you add it, here you subtract it, remaining value write as it is. So write here 6. I told in intersection point you added 6 plus 1 is equal to 7. Again one more intersection point is 2 plus 1 is 3, and subtract from unrelated row. 7 minus 1 is equal to 6. 7 minus 1 is equal to 6. Okay, so this is and 1 minus 1 is equal to 0. 7 minus 1 is equal to 6. So 2 minus 1 is equal to 1. 5 minus 1 is equal to 4. 0 minus 1 is, this is not line, so remaining value write as it is. Okay, now this is about the step number 6. After this again you go for that is previous method. Okay, now again you go for previous one, that is assign zero value row reduction method. Okay, na step number 1. So what you did in step number 1, assigning a zero values from the first row. Okay, here single zero is there, assign, delete respective column, come for second row, assign 0, delete column, come for third, the third is not there, and here third is 2 zeros are there, no use. Here 3 zeros are there, no use, and come to the for the fourth. So here also single zero is there, so assign that delete column. Once you completed the assigning a row wise, go for column wise. Here in column wise only single zeros are there, here assign this, delete it. Okay, again come for this row, here also single zeros are there, assign it and delete respective row. Now you check whether the solution is optimal or not. Here 1 2 3 4 5 are there, 5 number of square is equal to number of rows are there, therefore the given solution is optimal. So find the minimum total cost is job number, how many, write on the job 1 2 3 4 5 there, operator. So here for the operator, so first job is assigning a serial number, that is fifth. Second job is assigning 1, and third job assigning third, and second job you are assigning a 0, and the fourth one is assigning a fourth. So write on time, this is the values taken from the first, the given quantity, that is given box. Okay, na? For the fifth, for the first 7 values there I will show here. For first operator 57, so first one is 7 is there, you write here 7. Okay, next similarly you write on 6 6 9 6, you add summation of these, you will get 38 hours, therefore the total processing time is 38 hours. So this is the time taken to complete the job. So here from this diagram you are assigning each job to each contractor person. So again a first job is assigning a fifth contractor person, that is worker. Second job is operating a first, third operator job is assigning a third person, fourth is 2, and 5 is 4. So total processing time is 38 hours. So this is about the assignment problem 2, and what we solved, this method is called as a Hungarian method. Okay, na? Hungarian method, this method is called as a Hungarian method. I hope you understand this problem. Thank you.